In this video, we start to cover how you do full stack mutations. I'm starting from exactly the point I left off at in the basic server read section. And we're going to, we've got our basic data loading. We've used our targeting to move the incoming edge from this root edge to where we really wanted it to be. And this can be, anywhere in your state. It's just a path. Like for example, if I wanted to put whatever this loaded, I don't know, for some reason in a to-do item, I could target it to do item by ID 4 and some key with an entry of 3 items in this vector. So it's just like an associate argument. There's some special targets you can append to a list of things, prepend, replace. You can look in the documentation and find those things. The developer's guide is good for those, the server interactions. Okay, so we've got the data loaded. I'm going to go over to the server, and I'm going to make the server just a little bit more useful. This is part of the initial template code for doing something. Okay, I'm going to make a database on the server, and the hot code reload really hot code reloads on the server, so our database will just get wiped out, but I'm just going to call it our database is an atom that contains this map, and maybe we'll go ahead and sort of normalize it like we do in the client side. So I'm going to make this our to-do list database on the server. So it's nothing more than an atom that's holding a map keyed by the IDs of the to-do lists, and then let's go ahead and let's make this a little more complicated because we need things normalized for this to be easy to work with. So I'm trying to think how I want to do that so that it's not too complicated for you, the reader. You know what? I'm going to leave it just like this. I'm going to leave it sort of... no, I'm not. I'm going to put in our lists table, and I'm going to put in our items table. I'm going to go ahead and use our client-side notation because I can use the same functions. I can use some utility functions to turn this into what I need. So I'm just going to say this is items 4, and I'm specifically keeping this separate so you can see the database format doesn't need to match the client-side format. Right, but I've hooked it up as if these were tables in our database. What happened to my query there? Oh, I picked it up and threw it up there. All right, so now I'm going to try to answer the query that we got from the client. Now, like I said, I've got helper methods that I can use for this that are just built into the framework. There's a function called tb to tree that can take a query and some data and some more data. It's basically the database twice, and give me back an appropriate tree. So I can just kind of hand write a query here. The query that's coming to me, we've got printed out down here, is the query of a list itself. So I should be able to do that against starting basically here. So I'm going to leverage this query that I get. But in order for me to do that, I need to join it to lists, because that's what I have in my real database. If I start at lists, and if I join this on an ident 1, and so now I could actually use an incoming parameter, but I'm going to just hard code it at 1 for the moment. I want to run whatever query the user wants to run against a join on this ident. So I know this is slightly advanced join syntax, but remember our joins are just some key and a subquery. And so all I've done is for the key I've used an ident which locates a thing in a table. So I'm going to list 1. I'm starting here on my join, and then I'm running the subquery on it. Now I'm supposed to respond with that subquery, so I'm going to need to put this in a let, because what this is going to return me is the answer to my modified query. So I'm going to just call that data. And then what I have to pass this is, my to-do list database twice, basically. The reason for the repetition has to do with the recursive nature of this function, but when you're starting at the top, you can just use the database for both those arguments. Now, I want to show you what we're going to get back out of that so that you can understand why I'm going to do the next thing I'm going to do. So we're going to have to-do list. Let me restart the server. Can reload this. We're not going to get anything in the UI because I'm not responding right. I'm just showing you the intermediate step. So I ran that, and see, I got this join on lists 1 in the result. So the key in my return value is my join key. And then I've got the actual thing I wanted, right? I've got the to-do list with its name and its items, etc. So what I need to do is my result is a get from the data lists 1. Right, so I just have to undo this portion of the query that I hand built, so it's kind of symmetric. So now if I restart my server again, reload again, you'll see the debugging message now looks like exactly what I'd like to return. So let's return it. Restart the server again, reload, and now I'm back to where I started. Now, interestingly, if I flip over this, I talked in the last video about the reads. If I come back here to my to-do list, and let's say I stop asking for, I'm not using the list name, so let's say I stop asking for it, right? If I stop asking for the list name, and now I run this startup method, you'll see that I don't get the list name. I just get the ID and items. And that's because over here in my server now I'm using a function that properly parses the query and returns only what's been asked for. So already I'm at a data-driven app. I mean, admittedly, I did have to use a Fulcro formatted database to easily get there. But again, Fulcro pull syntax, Fulcro SQL, those two libraries do this for you. It's just a different function you call. All right. So we fixed that up. We now have a database. The reason I wanted this database is now it's in a format that's easy for me to modify on the server. So that's why I wanted to normalize that out and do this extra little bit. I can probably get rid of this little logging statement, restart the server, make sure that's still loading properly, go back and fix my UI. And you know what? We could actually go ahead and ask for list name and put that in here so we aren't so annoyed that our list is always called boo. Rerun it so it'll load, get the label. There's our my list. All right, so now this is starting to look sort of like what we'd like to actually have. But at the moment, if I edit one of these, of course, hit enter, reload, it triggers a load, and nothing got saved. So that's where we're at. That's what we're looking to do. So here's the amazing magic. I've got this mutation for changing an item label. I'd like to be able to change that item label and have it actually change on the server as well. I add a remote section to my client-side mutation. It gets the same environment that action gets. Typically, you don't need the environment. I return true. That's it. This is now a full stack operation. However, the server doesn't know what to do with it, but I do want to show you now that if I come in here and give it some stuff, you see it immediately starts sending it to the server, and actually that's not the one I want. Or actually I'm going to want to do it. I've got change item label, star, change item label. Oh, and I made those all one thing. So there's two things I'm going to want to fix here. One is I probably don't want to be that chatty with the server, right? I sent a mutation for every key press. And the server complained about every single one of them. But you see the server's getting a change item label mutation. It knows that's what it's supposed to do. And so we could actually go ahead and be chatty just for the sake of being a little more quick in the video here. So the mutations and reads in this template are separated out, and I'm going to go ahead and add it to this mutation API mutations. I'm not. So one of the things I've got going is my def mutations get namespaced to the place they're at. And actually def mutation allows you to override this, so perhaps I will go ahead and put them in this mutation CLJ. Typically what I would do is I'd make a mirrored namespace for the client and server-side mutations, maybe even use a CLJC file so that they're in the same namespace. Instead, over here, I'm going to use def mutation, and this is the server's def mutation, but it looks identical to the client's. And I'm going to use this fully qualified name. If I use a simple name here, it'll end up in this namespace, which won't be the right namespace. So I'm going to define that mutation, and you can see over here that gets parameters, and I care about the ID and text. Problem. Where did I put my database? Put my database in read. Oh, that should be okay. So I can just require demo.api.read refer to do, what was it, to do list database, I believe. Yeah. And then the action that I want to take in this particular case looks a lot like the client side because I'm using the same exact kind of. I want to swap on the to-do list database. I do not have access because I didn't code it to this mutation straight away, so I'll just go and kind of recode it. So I want to assoc in at items ID item label the text. Restart my server. My mutation should load. And now I get a different problem here. Arity exception. Number of args passed to assoc in on the database at this path. Oh, yeah, why don't we do that? And you can see my server is no longer complaining. I probably should put a log message in there. But let's go ahead and change that, and now let's reload the client, and we see now our label stuck. So that kind of is a indirect verification that the server's saving that state, because when I'm loading it, I'm getting it back. So mutations really are just that simple. You just have to write the server-side code that modifies the data in the database. And in this case, you've got the symbol to dispatch on of what the client asked to do, the same exact parameters that the client got. If you needed to modify those at all, so let me say as params, restart the server so we can see those. can see logged a little more than I meant to. What happened here? Status, body. Oh, I think log is not exactly what I meant to do. Yeah, invalid logging level. How about info? And notice my state's staying just as it is on these hot code reloads. Both in the client and server, I'm still editing the field. I've still typed A. I can now type B, right? And you can see I got YAB with ID5, C. And this part of the hot code reload is really cool. I can go to the server interactions page here, and I could say, for example, I decided that, when I'm editing this input field, to do item, when I'm in input mode, I've got this span. I don't know, maybe I really wanted in this LI, I don't know, just throw some text in there. Oh, I can't do that there because I'm in an if. Right? Updated, but if I go over and click on this thing, I'm still editing that field. I still have my state. Nothing gets lost. This is a lot more powerful than you're used to in JavaScript land. I mean, you could be inside of a modal, inside of an error dialog, underneath something 20 levels deep in your UI, completely refactor things and have it re-render while still being right there, not having to log in and click back through the interface and worry about your state, all this mutable stuff that didn't work right. This just works. So it's very beautiful. So you see, now we're getting those parameters. I mentioned what I was trying to do here was show you that if I wanted to, the incoming value environment for remote contains an AST, abstract syntax tree, of the mutation itself. And the guy has a params field. And I can actually return the AST as an alternative on the client side for doing the operations. You'll see here at hot code reloaded. I'm still getting the server interaction here. That's identical. But I can also say update AST at params and assoc an extra piece of data, so that I'm still returning an AST, but I'm augmenting the params with this extra thing, and that's on the client side. And so now you see extra ones coming to the server from the client. Isn't that cool that it just stays editing? So if you need that sort of thing, that's what that looks like. I thought I'd show that since it's such a simple thing to do. So that's your introduction to mutations. Your exercise is to go through and finish this to-do list.